Hi, welcome to my team's presentation. My name is James, and I am part of CSU Monterey Bay's team that is partnered with Sunereum Labs, a solar energy insurance company. My team has spent the past few weeks working on a way to make solar investments more resilient. For this presentation, we will show you how it started and the reason we chose this project. Then we will explain how we were able to gain an understanding of the solar energy industry. We'll walk through our journey, the highs, the lows, and the moments where we had to change directions. Finally, we will present our MVP, the minimum viable product that will help make solar investments more resilient. The solar energy industry is growing fast, but when systems underperform, asset owners lose revenue and trust. We want to understand how risk can be detected before it becomes a problem. My team consists of Walid Elgamel, Chris Tangonen, Josh Hong, and myself, James Mondragon. We chose this project because we care about sustainable energy and realize that solar asset owners often lack clear and accurate data. We devoted weeks to this because we saw an opportunity to make solar investments more reliable and transparent by helping stakeholders identify when actual performance falls short of what was expected. The solar insurance market that was introduced to us encapsulated many professions in various fields, ranging from actuaries, underwriters, solar developers, financial policy experts, and AI big data engineers. We were tasked with conducting interviews with these professionals. We were able to better understand the problem space using qualitative data from these interviews. Interviewing professionals gave us insights from those that are impacted by this issue. We also felt a more meaningful connection to this project as we interviewed beneficiaries and stakeholders. The problem we were given is as follows. Solar asset owners and insurance providers need accurate risk data and better insights into risk factors to bridge communication gaps, improve risk assessment, and ensure comprehensive protection for solar investments. Because the solar energy industry is relatively new, there is an overall lack of data, especially when it comes to issues that affect the performance and resilience of solar energy systems.
Thanks, James. Hi, everyone. My name is Josh, and next I wanted to talk about our journey over the course of this project. So at first, we were very excited about the idea of using blockchain because of its transparency and ability to automate claim payouts for solar insurance. However, as we dug deeper, we began to realize that the scope was too broad for our timeline and that it wasn't the core problem we needed to solve. This is when we decided to pivot and refine our focus. We shifted towards a more immediate solution, which is the decision-enabling solar monitoring tool. This tool compares expected versus actual solar generation and flags any underperformance issues, thus empowering solar asset owners to take a corrective action. Throughout this project, we encountered some highs and lows. We conducted weeks of interviews, and this experience was exciting as we gathered valuable information and insights from subject matter experts. The team spoke with several companies and learned just how far solar technology and data-driven strategies have evolved. The high points came when asset owners expressed genuine excitement about monitoring tools, especially those that compare expected and actual solar generation. A low point, however, was discovering the potential of blockchain technology for data verification needed to process claims. While the technology seemed promising, we realized it was too complex to integrate into our MVP at this stage.
Thanks, Josh. Hi, everyone. My name is Chris, and I'll be covering the mission model canvas. I think a good way to understand how it came together is by first revisiting the core problem we set out to solve. Solar asset owners and insurance providers need accurate risk data and better insights into risk factors in order to bridge communication gaps, improve risk assessment, and ensure comprehensive protection for solar investments. With that being said, we can break down our MMC into three portions. On the top right, we focused on the desirability aspect, linking our value propositions to the needs of our beneficiaries. This is where we started with broad hypotheses about the problem and refined them over the course of multiple interviews with stakeholders in the solar insurance space. Midway through the course, after several interviews, we clearly identified the core needs of our beneficiaries. Solar asset owners want consistent ROI, and solar insurance providers could benefit from improved risk assessment. This led to our desired solution in the form of a high-fidelity monitoring tool, which would require integration with existing solar asset monitoring systems, a UI for asset owners to view risk insights, and a cloud-based or API-driven solution for insurance companies. Now, as we move over to the left-hand side, from key partners to key activities to key resources, here is where we fleshed out the feasibility aspect of our desired solution by continually seeking interviews with beneficiaries, stakeholders, and also examining research papers relevant to our desired solution. Here is where we refined it to meet real-world constraints. It was in this feasibility phase in which we further refined our desired solution. Initially, it was envisioned as a high-fidelity monitoring tool, but through ongoing validation, we realized that value isn't just in observing risks, it's in empowering action. So we refined it into a decision-enabling tool, helping users take corrective steps when issues are detected. And finally, we cover the viability aspect, calculating the mission budget, examining operational, R&D, production, and distribution costs. We also explored potential funding sources and evaluated how well our solution aligned with our mission and long-term impact. Where the solar energy industry can benefit from our solution by having risk easier to mitigate and estimate. Solar insurance providers could benefit due to an overall improvement of risk analysis with a monitoring tool at their disposal. And solar asset owners could benefit on improved ROI and could also better detect when maintenance is required. And here are our VPCs, where throughout the interviewing process, we refined beneficiaries' pains, gains, and how our hypothetical solutions could assist the beneficiaries in both alleviating their pains and amplifying their desired outcomes.
Thank you, Chris. So what did we learn? We learned that solar energy systems are costly, especially for commercial and industrial installations. We also learned that solar energy production fluctuates based on many factors such as equipment capacity, the inverter efficiency, solar irradiance, and weather conditions, orientation and the tilt of the solar panels, even the snow and dirt accumulation, temperature, shading, wiring, connection losses, and tracking systems. How did we learn it? We learned it by interviewing professionals in the solar industry, researching some of the articles and the journal available to us, and also talking to stakeholders and beneficiaries such as solar assets owners. Here are just some of our companies and organizations that we interviewed. Who we interviewed? We interviewed different beneficiaries such as commercial solar assets owners, solar farm owners, insurance providers, solar maintenance experts, and solar energy builders, financial policy experts, and AI insurance experts. So throughout our journey, we were able to interview about 22 professionals and researched 15 journal articles correlated to solar industry and insurance market. These interviews assisted us with better understanding the problem space and cultivating an MVP for our primary beneficiaries. So let's have a review for our MVP. It's a decision enabling solar monitoring tool. A data-driven monitoring tool that compares the expected solar generation with actual generation for commercial solar assets owners. The tool highlights the underperformance or anomalies in the system output, enabling assets owners to identify potential problems with their solar system. While the tool doesn't give a specific fix, it empowers the users to take corrective action, whether that's reschedule energy use or repairing hardware or even upgrading the system, whether a storage capacity or even the system itself. So unlike the traditional models where expected solar generation is fixed at the planning stage, our smart enabling tool recalculates the expected yield dynamically. Let's have a review here. This is a curve that shows the dynamic expected versus the actual. Here is an example case for a case use. We can see here on the left, this is the total yield, kilowatt per hour. And we can see here the green is our expected average. What do we expect? And the orange lines are the actual that is going here. And we see an alert here. Once the difference between the expected and the actual exceeds a threshold system check, we are alerting. We are giving alerts. And as I mentioned again, it's really important to highlight that what we expect is not a fixed at the planning. Some manufacturer will have a specification for their panels and inverter, and the expected never change in the monitoring tool. We want to make sure that we adjust based on the performance as expected by design as well for the expected average. And this comes to the end. And just want to have a special thank you for our site supervisors, Seguta, the Sunereum team, and our program sponsor, Noble Reach Foundation, and finally to our professor, Dr. Bidusu. Thank you so much.